Hi, this is Sandy Chika from Riverside Brookfield High School, just outside Chicago, Illinois. I'm here to talk to you a little bit more about using programs with data. And in this video, we're going to look at the steps of processing information so programmers can gain useful insight and knowledge about the data. So, what will you learn? Well, I'm hoping you'll be able to extract information from data using a program. And in order to do this, we need to know that programs can be used to process data to acquire information. Tables, diagrams, text, and other visual tools can be used to communicate insight and knowledge from data. Search tools are useful for efficiently finding information. There's also data filtering systems that are tools for finding information and recognizing patterns in the data. And programs such as spreadsheets help efficiently organize and find trends in the data. Now, some processes that can be used to extract or modify information include transforming each element of a data set, filtering a data set, combining or comparing data, or visualizing a data through a chart, graph, or visual representation. So, again, that's a lot of things to say, a lot of words. Let's look at an example and see it in use. So, I have a data set here of 15 test score or 15 students with 3 practice exams for each student. This data I stored in a spreadsheet. I find spreadsheets to be an excellent tool to organize, filter, and analyze the data. But we're looking at a lot of numbers at here. There's almost too many to look at sometimes if I want to look quickly. So tables and graphs can help tell the story. So I took this data in the spreadsheet and used the spreadsheet to put together box plots. I have 3 box plots here. When I look at it, this blue box plot is for AP exam number 1. The bottom piece here is the minimum, the top is the maximum. The box represents the middle 50% of my data with a median line in the center. A median is just another way of finding an average. The same is true for each of these. The burnt orange is for practice exam 2, and the gray is for practice exam 3. I can quickly see a lot of things here. I can see that my minimum for exam 3 is higher than either of the minimums for the other 2 exams. I can see that the middle 50% definitely has increased for my final practice exam. Practice exam 2 definitely had an increase, but there was more of a spread. So that tells me maybe some of the students still were struggling a little until we got to exam 3. So I have a lot of information that I can just see from a picture. Often tables and graphs really especially are the best way to summarize data. If you ever have to give a presentation to a group of people, just giving them a bunch of numbers usually does not make them very happy. But when you can see the summary in a table or graph, it really helps things move along. I can also search for information. So I can use an algorithm that will find the minimum or the maximum for each exam. In a spreadsheet, those algorithms are already built in and I can easily select them. If I'm using a programming language, I might have to actually write those algorithms myself. I can also filter some of my scores. In this example, I filtered the scores based on who scored below average for that particular test. So I can see, well, some students scored below average in the first exam, maybe some of them again in the second, and some in the third, but some no longer were scoring below average. So I can start to see what students are consistently scoring below average, what students are always scoring above average. And that's really going to help me as a teacher to differentiate and give my students better examples of what they need to hopefully get them ready so they can really ace that AP exam on the real day. I can also search and filter. In this case, I searched to actually count how many students scored over a 50 in each of the exams. This makes me happy because I can really see that by exam 3, a lot more students were scoring at that higher end. So spreadsheets are very powerful tools. They have a lot of algorithms already built right into them. Those algorithms might use things like selection, in other words, if statements. They also probably use iteration. Basically, they're looping through every data point. And then I can iteratively do multiple searches, selections, and filters throughout my exploration of the data. I might not use a spreadsheet. I might use lists in different programming languages. This gives me flexibility to do anything I want as a programmer. We're going to visit lists and Big Idea 3 in more detail. So you might want to look for those videos if you want to hear more about lists and programming languages. So, what do I hope you're going to take away from this video? Well, we hope that you're able to extract information from data using a program. In order to do this, programs can be used to process data to acquire information. We also need to know that tables, diagrams, text, and other visual tools can be used to communicate our insight and knowledge gained from the data. We might use search tools because they're useful for finding information, and data filtering systems are tools for finding information and recognizing patterns in the data. Programs such as spreadsheets can help efficiently organize and find trends in the information. Some processes that can be used to extract or modify the information can include the following: transforming every element of a data set, filtering a data set, combining or comparing data in some way, and visualizing a data set through chart, graph, or other visual representation. Thank you for coming in to watch this video. I hope you're going to look at some of the other videos for CS principles and you find them useful. In the meantime, go out and have some fun with CS.